Good morning. It's June 20th, and this is your daily brief in science. Here's everything you need to know. Astronomers have made a groundbreaking discovery that could change our understanding of the universe. They have identified a massive filament of hot gas bridging 4 galaxy clusters, with a mass 10 times greater than that of the Milky Way. This filament, measuring over 10 million degrees Celsius, stretches diagonally for 23 million light-years through the Shapley supercluster, which is home to over 8,000 galaxies. The findings were published on June 19th in the journal Astronomy and Astrophysics, marking a significant advancement in understanding the connections between galaxy clusters and the distribution of matter in the universe. Lead researcher Konstantinos Mikas noted that this discovery aligns with simulations of cosmic structures, reinforcing previous astrophysical theories about the cosmic web that supports the universe's structure. For decades, models of the universe have suggested that a third of baryonic matter is missing. This discovery confirms that those models were accurate. Baryonic matter, which includes protons and neutrons, constitutes only about 15 to 16% of the universe, with a significant portion still unaccounted for, leading to the hypothesis that it exists in long filaments of gas. The particle density within this filament is about 10 particles per cubic meter, which is 30 to 40 times higher than the average density found in the universe. This filament is composed of ordinary matter known as baryons, which includes the atoms that make up stars, planets, and living organisms. Norbert Schartel, a project scientist for XMM Newton, stated that the discovery strengthens the standard cosmological model and confirms long-standing simulations. The research utilized the European Space Agency's XMM Newton and JAXA's Suzaku X-ray telescopes to accurately characterize the filament's properties by isolating its light from nearby cosmic sources. While future observations of similar filaments may be challenging, there are plans for new X-ray satellites designed specifically for this purpose. Additionally, the ongoing ESA Euclid mission, launched in 2023, aims to further explore the cosmic web and investigate the nature of dark matter and energy, which together constitute 95% of the universe. A new development in cancer care has emerged with the introduction of the early-stage Hodgkin International Prognostication Index, or EHIPI. This model represents a significant advancement in precision medicine for adults diagnosed with early-stage classic Hodgkin's lymphoma. Developed by a collaboration of researchers from R.W.J. Barnabas Health, Rutgers Cancer Institute, Tufts Medical Center, and the University of Manchester, the EHIPI model is based on data from over 3,000 adult patients participating in 4 international Phase 3 clinical trials. It has also been validated in 2 real-world registry cohorts comprising more than 2,300 patients, showcasing its strong and consistent performance. The EHIPI model builds upon the previously established AHIPI model for advanced-stage Hodgkin lymphoma, integrating treatment regimens to enhance personalized predictions for future research. By utilizing common clinical variables such as patient sex, tumor size, and laboratory results, it predicts the likelihood of remaining cancer-free for 2 years, thereby aiding in personalized treatment planning. Notably, EHIPI has outperformed the existing European Organization for Research and Treatment of Cancer classification system and includes interactive online risk calculators to facilitate decision-making between clinicians and patients. Dr. Andrew M. Evans, a leading researcher in this study, highlighted the model's potential to improve clinical decision-making and long-term outcomes for Hodgkin's lymphoma patients. The findings of this research were published in the New England Journal of Medicine Evidence and presented at the 18th International Conference on Malignant Lymphoma, underscoring the significance of this work. Supported by the Holistic Consortium, which combines data from major clinical trials and cancer registries, the research promotes the advancement of precision medicine in Hodgkin's lymphoma care. Future efforts will focus on refining the EHIPI model by incorporating treatment regimens and estimating long-term consequences post-therapy. Dr. Evans emphasized the importance of having a validated tool to assess relapse risk in early-stage classic Hodgkin's lymphoma, a highly curable cancer, aiming to provide a more individualized approach to patient care and enhance overall management of Hodgkin's lymphoma. Depression is a prevalent mental health condition, affecting approximately 9.2% of Americans each year. Despite its widespread impact, many cases remain underdiagnosed, with only about 30% of patients responding effectively to initial treatments. A new study published in Biological Psychiatry sheds light on this complex issue, revealing that multiple brain profiles can lead to the same clinical symptoms of depression. This indicates both one-to-one and many-to-one heterogeneity within the condition. Researchers from the UK Biobank conducted an extensive analysis to explore the relationship between clinical symptoms and neurobiological profiles. They aim to determine whether a direct or complex mapping exists between these two aspects. The findings underscore the clinical importance of accurately subtyping depression to ensure patients receive the most effective treatments. However, it is important to note that the study's findings are primarily limited to older adults. John Crystal, MD, editor of the journal, emphasizes the critical role of accurately subtyping patients for effective treatment matching. The study advances this goal by linking clinical assessments with brain imaging findings. Co-investigator Deanna M. Barch, Ph.D., advocates for future research to refine depression subtypes by addressing both clinical and neurobiological heterogeneity, aiming to enhance treatment outcomes. The research identified two distinct subgroups among patients with acute depression. One group maintaining normal cognitive function, while the other exhibited significant cognitive impairment. This highlights the inadequacy of standard questionnaires in capturing the full spectrum of depression. Notably, neuroimaging played a vital role in revealing variations in depression that clinical assessments alone may miss, aiming to improve future clinical care and treatment effectiveness. One neurobiological profile identified in the study was linked to worse cognitive outcomes, suggesting that MRI scans could predict clinical outcomes beyond what standard symptom screening can provide. Researchers from Lawrence Berkeley National Laboratory and Stanford University have made significant discoveries regarding enhancers, the regulatory DNA sequences that play a crucial role in controlling gene expression during embryonic development. Utilizing a mouse model, the team investigated 7 human enhancers linked to critical developmental processes. Their findings revealed that mutations in these enhancers could lead to unintended gene activation in tissues such as the heart and nervous system. The study, published in Nature, highlights the importance of multiple modular sequences within enhancers for proper gene expression. Even a single nucleotide mutation can dramatically alter gene activation, suggesting important implications for understanding human disorders and designing gene therapies. This emphasizes the need for caution when developing tissue-specific interventions to avoid unintended effects. The complexity of enhancer functionality, coupled with a lack of data, has made it challenging to create accurate predictive models using machine learning. However, the research team has generated a large experimental dataset to aid in this effort. A new AI model developed by Stanford collaborators aims to identify important enhancer sequences, but has been found to miss some critical areas recognized through experimental evidence, highlighting the limitations of current predictive models. The study serves as a reminder that while AI can aid in understanding enhancer biology, it must be complemented by experimental biology to ensure accuracy. Researchers faced challenges in investigating enhancers due to their complex binding sites for transcription factors, which require systematic experimentation to understand the effects of mutations. Supported by the National Institutes of Health, this research contributes to the ongoing exploration of gene regulation and the role of AI in enhancing our understanding of biology. First author Michael Kosicki emphasized the importance of these findings for understanding gene regulation and their implications for human disorders and gene therapy design. Co-lead author Len Pinocchio cautioned that single nucleotide changes could have significant developmental impacts, underscoring the need for careful design in tissue-specific gene therapies. Overall, the findings indicate that existing machine learning models, while accurate, may overlook critical sequences essential for enhancer function, reinforcing the necessity for experimental validation. New research from the University of Sydney has unveiled significant findings regarding the impact of heading a soccer ball on brain chemistry. This study highlights that even in the absence of concussion or cognitive symptoms, heading can induce changes at a microstructural level in the brain. Co-author Danielle McCartney emphasized the need for further investigation into the long-term implications of these changes on brain health. In a controlled environment, players who headed a ball 20 times showed elevated levels of two proteins, GFAP and NFL. These proteins are biomarkers associated with brain injury and an increased risk of dementia. Notably, while participants did not exhibit cognitive impairment, the study concluded that heading can disrupt brain cells without presenting obvious symptoms. The research has raised concerns about the potential links between heading and dementia, prompting calls for caution among players. Some countries have already taken action, prohibiting heading in training for junior players. The English Premier League has also limited players to heading the ball only 10 times per training session. In response to these concerns, Football Australia has initiated a project to review recommendations related to heading in youth football. Countries like the United States and the United Kingdom are implementing restrictions on heading in youth soccer, and Australia is considering similar measures. Former soccer player Dean Windass has publicly shared his battle with stage 2 dementia, attributing part of his condition to his career spent heading the ball. This study is particularly noteworthy as it is the first randomized controlled trial to utilize MRI scans to assess the impact of heading on brain function. MRI results revealed subtle changes in brain chemistry, especially in areas related to motor control, along with decreases in electrical conductivity across several brain regions. Lead researcher Dr. Nathan DeLange stated that while the study does not definitively prove that heading causes dementia, it suggests that routine symptom-free heading may still have implications for brain health. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.